cycle. So with NA bar as an input signal, if it is received by your processor, that indicates that hardware, external hardware, is capable of handling multiple buses, right? So multiple buses. So what next address indicates what? Key, your external device is requesting for the next address, right? So next bus cycle can be initiated. Now, the next to this is the ready bar signal. Now, ready bar signal is basically bus ready, right? This is basically an acknowledgement signal. This is basically an acknowledgement signal. Now, what this acknowledgement is going to indicate, that I want to elaborate here. Right. Now, let's take one example, that you are sending data, right, to the memory, right? In one of the memory location, you want to write the data, right? So it is a write operation that. So what processor is supposed to do? Now, when we say that it is a write operation, so you can easily imagine the data flow direction, right? Data flow direction. So when you say write, so can anyone tell me, right, what is exactly the data flow direction, right? From where data will move, and which will be the source and which will be the destination? So I will ask question to Ayush. Ayush Petkar. Please unmute yourself. Ayush Petkar, am I audible? Ayush Petkar.
Hello, sir. Am I audible, sir?
Yeah, you're audible. See, right operation, right? So when we say write operation, data will flow from which source, and it will be sent to which, what will be the destination? That is the question.
Sir, can you repeat the question? My network is not stable.
Yeah, my question is, my processor is performing write operation. Processor is performing write operation. So which entity will be the source and which entity will be the destination? And two entities are CPU and memory. Entity one is CPU, my processor, and entity two is my memory. So if
CPU will be the source.
all right, very correct, and destination will be the memory.
Yes.
Yeah. So when we are performing write operation, right? So processor is sending data, but how processor will understand that whatever the selected address to for this particular operation, the data is successfully stored there. For that purpose, this acknowledgement signal is used. All right. I think this is very simple understanding of this ready bar signal. Right. Now, with the read operation, your data source will be the external device like memory, right? When we are talking about the read operation, then memory will be the source and processor will be the destination, right? Processor will be the destination. Now I will ask question 2. So let me select Shivraj. Are you there? Because I think Shivraj. No. Whenever I am asking question, people are leaving the meeting. This is a very interesting practice that students are doing, right? So I think I should mark them absent. So okay. So Varun, are you there? Varun? Varun, am I audible? Varun, are you there in the class? Unmute yourself. Parth is there, Parth Dake.
Yes, sir.
Yeah. So we got the answer about the write operation, right? Now, in case of read operation, which will be the source and which will be the destination,
The source will be memory and the
right?
destination will be the CPU.
And CPU, your processor will be the destination. Now, here, let me tell you that when we are talking about this ready signal, right? Now, this ready bar signal, when we are performing write operation, this indicates that the data which was sent by CPU is successfully stored to the destination, right? When we are performing write operation. But in case of read operation, this signal will be indicating that whatever the requested data, right? Whatever the requested data, it is successfully placed on the data bus, right? It is successfully placed on the data bus, and processor can read that particular data after receiving this ready signal, right? So there is a difference of that particular meaning of that particular signal when we are performing write operation and read operation, right? So in case of write operation, this signal indicates that whatever the data which was sent by your processor is successfully sent or stored to the destination. But when we are talking about the read, this signal indicates that requested data is available on the data bus, right? Whatever the requested data, it is available on the data bus, and this signal will indicate that processor can read that particular data. No, so valid data, whatever the requested data, it is available on the data bus. So later on, processor can get that particular data. So after receiving this ready bar signal, processor will get that particular data into the destination register, right? So this is what the meaning of this ready bar signal. Then next is a BS16 bar. This is basically bus size 16, and with this particular signal, your processor can dynamically select the bus size, right? By dynamically select the data bus size. So now what this bus size 16 is, so this is basically the input signal, and it allows direct connection of 32-bit and 16-bit data buses. So we can connect the 16-bit data buses or 32-bit data buses to the processor data bus, right? So dynamically it can select, bro. So if your motherboard is having 16-bit data, so in that case, this signal will indicate that the bus size is 16-bit. Only the lower 16-bit data bus is to be used for all data transfer operations, bro. So here, this signal is the signal sent by the external hardware to indicate that the current transfer, processor has to use only 16-bit data, right? Your processor 80386 is having 32-bit data. So we have both options, right? So this is basically used to connect the 16-bit data buses to the processor. The next signal is hold signal. This is a bus hold signal, and the associated signal to this is a HLDA, right? So that is a hold acknowledgement, right? Now this bus hold signal is called as bus hold request, and this is the input signal sent by the other bus master, right? When we discuss about the DMA and all, here other bus masters can take control of system bus, right? And on motherboard, basically we have one system bus, and on that particular system bus, only one bus master can at a time send or at a time have control of this system bus. So if the primary processor is having control on the system bus and other bus master wants to use the system bus, in that case it has to take it has to send the request, and that request from the other bus master will be received by your primary processor on this hold signal, right? And after receiving the signal on hold, your processor will acknowledge with this particular signal, and that signal is called as HLDA, and this is the output signal. So this is bus hold acknowledge. So now once this HLDA is released by your processor, in that it means that your processor has completed the current bus cycle and it has paused its operations, right? If there is any bus operation, it has paused, and then it has released the control of system bus to the requesting bus master, and requesting bus master can initiate its bus cycles. Getting this? So this is very interesting set of pins, right? So hold was the input signal on which it receives the request, and HLD is the acknowledgement signal, to send the acknowledgement indicating that other bus master can take control of the system bus, right? So next is a busy bar, error bar, and PEREQ bar, right? Busy bar is these all three are the input signal and associated to the coprocessor interface. And this signal, a busy signal, is a busy condition from a processor extension. So when you say processor extension, that is a coprocessor, right? So here this input signal busy bar will be indicating that your coprocessor is busy, right? So while executing the instruction, it takes more time. So to indicate the condition, right, execution condition, it uses this busy bar signal, and this is the busy condition will be indicated to your main processor, right? This is basically happening. This is basically used for synchronizing the data transfer operation, right? So for operand exchange and all, this particular signal, busy bar signal, is used, right? Then error bar signal is there. This is basically indicating the error condition of your coprocessor. If there is any error, then ultimately this error will be indicated on the error bar signal. And then PEREQ, right? So PE is processor extension, and REQ is a request. So this indicates that processor extension has data to be transferred right. In that case, your coprocessor cannot do the data transfer operation, so that is to be controlled by your main processor, right? And your coprocessor is basically used for performing operation on floating point numbers. So in that case, for data transfer operations, it has to send that request to the main processor, and main processor will take care of it. Now, when we are connecting coprocessor in our system, and we write code for coprocessor, in that case, initial execution part, right, decoding part, will be handled by your main processor. And once it understands that it is a coprocessor instruction, then latter part will be handed over to the coprocessor, right? Then INTR is there. INTR is an interrupt request. As I told you, interrupt request is the hardware interrupt, one of the hardware interrupt, and this is called as maskable interrupt. Maskable input. It means that when we want this interrupt is to be serviced, then we have a interrupt enable flag, and we will make that particular bit as 1. Right, and if you don't want that this interrupt is to be serviced, right, you want to mask it, right? So you can simply make IF bit interrupt enable flag equals to 0, right? So this is a maskable input that signals the 80386DX to suspend execution of current program and execute an interrupt acknowledge function. So when we write interrupt acknowledge function, that we alternatively we can call it as an interrupt service routine, right? So interrupt service routine for that particular interrupt will be executed, right? So there are several things behind this interrupt service that is there, but that we will cover when we talk about the interrupts specifically about the 80386. But here you must highlight that INTR is a maskable interrupt, and can having flag IF flag, interrupt enable flag, right? And based on the condition of IF, it will decide whether the interrupt signal received on INTR will be serviced or not. The next signal is NMI. NMI is basically non-maskable interrupt. So non-maskable name itself indicates that we cannot mask. So we don't have any control, right, of masking and unmasking this particular NMI. But there are several conditions, right, which we will elaborate in interrupt related discussion. But as a label indicates that it is non-maskable, so we don't have any flag associated to NMI to enable and disable this. So if there is an interrupt, it will be serviced by your 386. So it will suspend its execution, right, and then it will execute its interrupt service routine, right, and interrupt acknowledgement function we call it. Then next is a reset, right? It is input signal. This suspends any operation in progress, right? So ultimately, reset is another, we can say it is a non-maskable. So if there is a reset signal, it is going to suspend the current operations and then places 8036 DX in non-reset state. So when we say reset state, then we have seen the initial registers contained. So it will enter into the reset state, right? So here, this reset is the third interrupt, right? Hardware interrupt, right? Then there are several pins, NC pins are there, and those are basically no connections are there, and those always remain unconnected. So connection of NC pin may cause the processor to malfunction. So there are some warning messages are given, but these NC pins on the processor, right, will not be actually connected on motherboard. Right, there will be a pin and the socket on the pin socket for processor, but actually those pins are not connected on motherboard. Then VCC and VSS are two power supply. VCC is a power supply that provides plus 5 volt nominal DC supply input, and VSS is the ground, system ground. So that provides zero connection from which all input and output are measured. So these are the different pin functions which are there. Now, exam point of view and the understanding point of view, there are different groups which we will be repeatedly using in our further discussions, right? Now, in what case these pins will be used, right? So whenever you are designing a system, right, on a motherboard, right, whatever the connections that we are making, right, in that case, while designing the motherboard and hardware system design, in that case, these pins will be helpful, right?